But telescopes are just one of the technologies being developed at the LOMO plant, and we've come here to St. Petersburg to look at some of the others. But it's a little late tonight to do any real work, so I'm going to take one of their early inventions out for a walk and get lo-fi with a LOMO. This is the LOMO Compact, a film camera that used to sell for a couple of dollars and has now become something of a cult classic. What makes it different? It distorts colours, leaks light, and produces pictures that are, well, just a little unusual. Its fans call themselves lomographers and even have their own philosophy. Don't think, just shoot. You never know what mundane image will come out of this magic box as a masterpiece. Lomography clubs have been established all around the world, and we met up with the St. Petersburg branch as they had one of their regular meetings. By the end of the 80s, the Compact was a dinosaur. Demand had fallen and LOMO were about to discontinue production. But the Compact got a reprieve from the death penalty when the founders of the movement, Wolfgang Stranziger and Matthias Friegel, picked up a Compact for a few holiday snaps and were blown away by the results.
The point of lomography is that you don't have any rules. So you don't need to wait for some subject to appear, for some beautiful landscape. You can shoot anything you like. Any person can become a lomographer. Everybody has digital cameras. And I've got another type of cam, and everybody look at it and say, oh, wow, what it is? I say that it uses film. Film? Oh, it's so old. Nobody. But I say that it's my lifestyle. I like it analog. It's warm. I like to be special.
Of course, with all the smoke and mirrors now available in this wonderful age of digital technology, it is possible to recreate that lomographic effect. But what you can't recreate is that unique opportunity to capture a moment in time from a slightly different point of view. So while their compact camera may be their most famous and kooky invention, it really is just the tip of the iceberg. Because for the past 100 years, here at this factory, LOMO have been producing cutting-edge optical technology for every conceivable walk of life. From high-end astrological telescopes looking far into deep space, mass-produced cameras for home photography, innovations for the cinema that changed the way we see films, targeting and reconnaissance equipment for the military, and microscopes that can give us crystal-clear pictures inside individual cells. Originally founded in 1914 to make gun sights for the Russian military, LOMO quickly branched out. By 1930, it had produced the first Russian-made camera. Night vision devices and telescopes accounted for 30% of the company's exports, Germany being the largest importer of LOMO products. And when the Soviet astronomical program had the idea to create the most powerful instrument in the world for exploring outer space, it wasn't too surprising that the call went to St. Petersburg, to the multi-talented lens makers of LOMO, to make it. In 2008, the company is still in international demand, currently creating parts for high-tech flight simulators. They have the expertise to create small to mid-range products, but lack Litkarin's capacity to forge and polish mirrors in the 6 to 8 meter range.
We've been cooperating with Litkarino for quite a while. In particular, they provide us with optical glass, which we process. This machine produces mirrors for training simulators. And the other machine produces mirrors for telescopes in Germany. This telescope has a 1,000mm diameter main mirror. It's parabolic. The secondary mirror is a hyperbola. We produce it as well. Its diameter is about 300mm.
As well as producing huge one-off made-to-order projects, in another part of the plant, they're churning out massive quantities of these little chaps. Tiny lenses for use in top-quality medical strength microscopes. And although the scale is drastically different, the quality and accuracy of what is produced has to be 100% the same. Despite being mass-produced, in order to be effective in analysing the tiniest details of single-cell research, these have to be just as flawless as the lenses looking deep into outer space.
This laboratory makes optical elements for microscopy. They produce components for lenses and eyeglasses. Our enterprise is the leading producer of microscopes for crime detection units, metallurgy, and many specialised scientific instruments.
Once the lenses are produced, they have to be stringently tested to an accuracy that would make a pinpoint look like a ballpark. Computer analysed for the most infinitesimal of imperfections, only then do they move to the assembly line, where they are combined and transformed into tools for use in the exacting arenas of medicine and science. LOMO don't only make the lenses, but actually manufacture the entire end product. The lenses are combined within microscopes to give different factors of amplification, but each one has to be able to record a precise focus in order for this process to work properly. Once the optical eye is complete, elsewhere in the factory it's combined with the viewing mechanism that enables it to be used effectively. LOMO sell thousands of these high-quality microscopes and have clients all over the world. Recently, LOMO have gone beyond microscopes and into microvision, a hybrid of conventional microscopes and optical software that increases our ability to see deep inside the hidden world of the super small. It's a new take on an old system. The image seen through the lens is fed through an internal processing system that transforms it into a digital visual display. It has a 1 megapixel video matrix and the ability to catalogue previous images on an internal memory or transfer them to a portable flash stick.
This device is unique. There's nothing similar to it. It's very practical for educational institutions as it provides visual aid while studying. It can display pictures and save graphic files. It's very convenient for the user.
The advantages of the digital display make the microvisor much more useful than a conventional microscope as a teaching tool. And it also has the advantage of being able to clean up areas with a low contrast and is better able to maneuver around tiny parameters precisely. It's a new market for the company and one that is growing every day.
As a microvisor is a novel product, it's in growing demand. Today we estimate its production volume as about 20% of all traditional microscopes. In future, we hope its production will only grow, and its sales will be as much as of traditional medical microscopes.